In the previous episode, we created a dirt block and we have instantiated this block a few times by drag and dropping the scene into the world scene. So the first problem we have with this block is that it only shows a dirt block, a dirt texture. So if we do want to change this and display different blocks, which will be mandatory at some point, we do have to update how the block scene is working. The very first thing we will do in order to prepare the upcoming changes is to clear what we did in the first episode in the sense of removing the forced built-in textures. Also considering that at some point I did misclick and add the materials on the geometry instead of the mesh. But that's alright, because that was temporary anyway. So here we have the empty block. If we want to be able to make the block display different textures, we need to kind of have the script do that for us. So it means that we do need to script this block. Script this block means adding a script, create a class name for the block, and then create a few methods, properties and stuff, which will be very useful. The first behavior we will create for this block is create a property in the inspector right there, a property that will allow us to define what texture we do want to create and add to the block when it is loaded. When you want to create a new property in the inspector here, we need to use the tag expert. The reason why we want this to be expert is because it will be written on the disk. And here is what is written on the disk, basically summarized. So we want this variable to be exported. And here we will have the name, which I will name material, and it's going to be a standard material 3D. I'm choosing this because the dirt material here is a standard material 3D. Which means that now, when we are looking at the block, we can say that it's a dirt block by loading the dirt material. Now that we have loaded the material, it is quite necessary to actually apply this texture to all the faces. So we need to see how we can do that with the script. So we're going to create a function which is apply materials. It will return nothing, and at the moment do nothing. In order to access those faces more easily, I will make those unique by using the add unique name options. And now all we need to do really is to reach those faces. So we will start with the east face. We will type it for the script so that it knows what we are working with here. And in this east face, what we want to do is to change the surface material override to basically dirt. The way we change this is not by directly changing the property, but by using a method which is set surface override material. This method takes two arguments, the surface as an integer and the material as a material. The surface is this 0 right here, it is the integer. And the material is empty, it is null, so here it is. It's going to be the one we have loaded and exported. So what we will do is use the 0 and bring in the material that we have configured at the top of the block here. So this is one line. Now we can duplicate this line for every face and just change the names to make sure that we change all the faces. So now that we have a function which does update the textures or the materials, we only make sure that in order to have this block ready, so when we load a new block, we basically apply the textures. Okay. So here by default, the block is going to be using the dirt material. So if we do watch the blocks in the world here, they all use the dirt material. So when we start the scene world, we should have dirt blocks as usual. However, now we're going to import a new texture and we will create a new material. So I created a stone texture. I will change the properties to make sure that it is properly pixel perfect. And now I will create a new material for this texture. So because there's quite a lot of things we have modified in the dirt material, I will just duplicate the dirt material with Ctrl and D, and I will rename it stone. Okay. This stone.res, I will just change the texture, quick load the stone texture PNG, and we are good. Okay. So now by default, all these blocks, they have the dirt material. So I'm just going to change a few to load instead the stone material. So we're going to have a stone here, and one here. Now when we start the game, we do see that we do indeed have the blocks loading as stone. The only thing we have done is creating blocks by manually drag and dropping the block scene within the world scene. On the long run, this is not how the game will work. We will want the game to be able to create blocks by itself without having a developer behind the wheels drag and dropping things. So we will go in the world and we will also add a script to that world to see how we can instantiate and create a block by using the script and not using the editor. So here I am creating a new method, which is the method create block. So let's start easy and just take care of the very first thing we want to do, which is adding a new node to the scene. This is actually very easy to do, but it may be a little bit intimidating when you don't know how it works, so I'm going to go through every steps so that you don't miss any and make sure that you understand what's going on when you want to reproduce this. The very first thing you need to do is to get an access to the scene you want to instantiate as a node. I'm creating a variable scene with the type packed scene, which is basically what they are when you load them from the disk, and we will preload the block.tscn scene because it is the one that we will instantiate. Okay, so this is getting access to the scene with the path toward that scene. Number 2 is create a node by instantiating that scene. So here we will create a variable node typed block. Here we're typing this block because it is the type of the scene. When we attach a script to a scene and give a new name to that script, it creates a new type for that specific scene. So here we have a variable node block, and we get the scene that we loaded previously. We use the instantiate method built in the packed thin resource, we instantiate it, and we type it as a block to make sure that the editor knows that we are working with a block here and we are putting a block in a block, basically. The third thing you want to do is to apply the relevant transformations. So here the relevant transformation will be, for example, the position. So in the arguments of this function, we will add the position as a vector 3, and I will just leave it like this so that you can see the warning. We have a warning which says that the parameter position is shadowed. Yes, it is shadowing an already declared property. That's because the world right there, it has in its transform a position. Okay, so here we do want this position as an argument to be separated from the one here, so we do use an underscore just to make the difference between the two. Now that we do have this argument position, we can apply that transformation to the node that we received. So the node dot position, which is the position of the block, will be the position that has been specified in as an argument for this call. Once you have done the relevant transformation, the very last thing is add the node to the scene tree. So when you add a node to the scene tree, it basically has to be connected to an already existing scene. This comes in the form of calling the method addChild to an already existing node. So you can either call a distant node if you do have a reference to that node, or you can do it on yourself. Here this script will use the addChild on itself. And because the script is attached to the world, it means the block will be a child of world. So here we just use the addChild method and we specify what node we want to add, and it is the node. All right. So this is the method that we're going to use to create a block. So let's actually use that method by saying, for example, that we do want to create a block at the position, and to define a position we need to create a vector 3. We want the block to be in 1, 1, 1. Okay. So if I just run the game right now, we can see that we have a block popping here. Maybe we want it to be in the negative instead, I believe. So here we have this 1, we could go with -1. And it's going to be a little bit, yes, it's somewhere a little bit easier to see now. Okay, so that's pretty much how it works. I wanted to see how this node that we created manually, how can we actually kind of inspect it when it is running during the runtime? We go in the scene tree here, and instead of using the local scene, we use the remote scene, which is the one in the game currently running. So if we go in the world, we will see that this block right there, static body 3D2, is the new block we have created. So we can't really see it because this is not the in-game view, but yeah, it is here. And it has a weird name, so maybe it could be interesting to give a understandable name to our node. So here we will just add the node.name. We'll change the name of the node to be equal to, let's say, its positions. So these are the basically the coordinates of the block. So we're going to use position.x position.y and position.z. Okay. So now if we rerun the scene, go check the remote, we have the 1, 1, minus 1. So that's great. The only problem we have is that we can only generate dirt blocks. So yeah, there are many complex ways to go through that to make this sort of automated and easy to use, easy to scale, but it takes a lot of time, and honestly, I do think it's not necessary right now, and we will do that later on once we have a little bit more features on the very first prototype. What we will do instead at the moment is create a variable here, which will be our materials. So I'm going to create a variable materials. It's going to be an array of standard material 3D. Okay. And in there, we will have two materials. We will have dirt and stone. So what I'm doing here is kind of doing a tiny database with the materials, and I will allow the script to choose what material we want to create. So here we do want, when we create a new block, to say that the node dot material is going to be equal to something different. So here, as you can see, there's an underscore before material, which means that I did not intend to manually change this value and access it, and basically have a script changing it from outside its own class. So I will create a function for this. So I will create a function which is set material. And yeah, I will have material equal to the argument that we create here, standard material 3D. And that's pretty much it. Just adding a quick note here, it is actually very important to say that the material is equal to the argument where we do want to update the material. It is something that I very often do, just leaving standalone expression like this. So I'm fixing it right now so it makes sense for you. So we go back to the world, we get our node, and we access the set material. And let's say that, well, we do want to choose, is it going to be dirt or stone? So we'll have two ways to go with that. We could just drop it here, but technically we do want to allow the dev to choose what material we have in there. So we will have a single material here. So that's standard material 3D. Okay. And here we want to throw in the material, which comes from the argument. So now when we create a block, we do need to specify what material we do want to add. So here materials dot index 1, which is stone, is going to be used to create that block. Run the scene, we do indeed have a stone block and not a dirt block. So by using this method, choosing the material and the position, we can create blocks as we want. So technically we can think about adding as many materials we want, and we can create blocks pretty much anywhere. So here, let's just imagine that we have a block of dirt, so it's going to be material 0. And this is going to be vector 3, something in the line of 1, minus 3, minus 10. I don't know if we even will be able to see it. Yes, we can see it quite far. So that's it for this episode. That's all we will do today. I don't know what will happen in the next episode for the next week, so I can't tell you exactly what will happen. Eventually, there will be character movement and mobility that could be interesting, but we never know. If you did like this video, please think about liking and doing all those YouTube algorithm things. If you do want to support the channel a little bit further than that, you have access to the Ko-fi link in the description. And yeah, I hope you do enjoy this series so far. You keep practicing because this is how you get better at making games, and I will see you in a next episode.